Welcome to our structural modeling video conference for September. We have a lot of material and talk about this month. A lot of progress and interesting things going on. So a little bit of a couple of unique things about our setup that we've been using. First is today we have Kevin Dye on the phone. So he won't be, his photograph won't be on the browser bar because Kevin is available just by audio on the phone. He's traveling. And the other thing is that Google has deprecated Hangouts on the Air, and what we'll start using next month is YouTube Live, which I haven't used before, and I'll be setting that up in the next few weeks and sending out information to people about how we're going to go with that. So is there anything that people would like to talk about or make sure that we discuss this particular meeting before we get started? Okay, so that basically then let's start with the read ahead document. I sent out an overview of a presentation that got accepted for an open source conference. And what I'm going to do now is just bring that document up and share it on the screen with everyone so that we kind of have a little bit of a conversation about this. It's interesting to me from a couple of aspects. And the first one is the time of the development of the ISM algorithms, when they were, what type of computing capability was available, what kind of compilers, what kind of networks, those types of things. And of course that really impacted the way people created the software to implement the ISM, and also thought about how they would work and architect their system solutions. So in the Seattle area, they're having a GNU Linux conference that's focused on free software and the value of free software. And due to the fact that I use so much free software in the analysis of the ISM and the structural modeling approach, I decided to put in a presentation which was accepted and will be given in November 11th and 12th here at the local Seattle Central Community College. And I'm going to talk about the differences between the algorithms and the way the computer programs were written back in the 60s and 70s, and the type of tools and the way we look at things now. And the primary part of this is two primary parts, really. One is the open source piece that goes with the mathematics. So at the University of Washington, the mathematicians there were becoming concerned that a lot of the mathematics software was closed source. That was Mathematica, MATLAB, things like that. Most all of these mathematics tools were closed source. So they started taking the open source mathematic tools that were available and put those together into a product that's open source, built with Python, that people can use to do their mathematics, but also look at the code, understand it, check it, make sure it's right, and to do what mathematicians like to do, which is verify the logic behind the computations, which you can't do with the closed source. So we use that type of open source software with the mathematics, which really kind of fits into the slot when structural modeling of the mathematical structure. So that helps us tremendously to have a structured, verified set of software that supports the mathematics structure piece. And then the other part that I found was that due to the fact that there was really no standard compilers, and these people were really basically writing in assembly language and so forth, they really didn't have common data types. And so the utilization of number systems and so forth, and like the augmentation of Boolean algebra that Warfield did, and was very easy for them to do because they were writing all of the logic that implemented their code, and they really didn't have the restrictions of the data types. And so today, the Boolean data types are really restrict some of those operations. So this talk will be about how to use open source to facilitate this specific activity and how it fits into the structural modeling approach now, and how we can use it to further develop the structural modeling and ISM methods. So that's kind of what the read ahead was about, and what I'm going to be doing in November. And I've asked Kevin to actually do part of the presentation, and so that he can, communicate the value of the open source piece. We want to do an open source test bed, a couple other things, and I'd like to have Kevin comment on that now, if he would.
Yeah, well, we've kind of cultivated that story over the past couple years at the INCOSE conferences, and then most recently in drafting the objectives of the overall project as a context for the systematic review paper we're planning to do. So we have a pretty well fleshed out set of objectives, which you can interpret the value, what we perceive the value to be of building platform. So I think that should, we pretty much have all the material for November already to talk about the value of doing the project.
Well, that'd be great. So, if possible, I'd like to have you, online with a video link, just live presenting. I don't know if we can hook that up, but if not, then record a video that I can play, basically, as part of that process. And if there's other people that could add to that, the value of the open source piece, I think that would really help, because this might be a place where you're going to find people that if they're intrigued with this approach and see value behind it, they have the skills to help develop the software and the infrastructure and make it happen. So might be an opportunity to introduce a completely different community to what structural modeling is, what ISM is, why it's important, and how it can help folks. So,
yeah, for example, if we came up with a customized version of the ISM around project planning, then people in the open source community could use it to coordinate their efforts on a bigger project than an individual could be doing.
Exactly. Yeah, those are exactly the types of things that would be very valuable, and also other examples of people that have used the closed source and why they want to use open source now, things like that. It's a little bit of motivation. anyway, I think that'll be a really good event, and start, as I said, introducing a different community to this type of activity. And the structural modeling activity really needs a number of professional communities involved in coordinating together. One, of course, is the mathematicians. The other are the computer scientists folks doing the algorithms. The other one are the people that are dealing with complexity on a day-to-day basis, like organizational complexity and social technical systems. And then another group, of course, is the systems scientists and systems engineers that are architecting and putting these components together to create effective systems. So this particular interface that I'm hoping to develop now to the open source community is really more to the people that are associated with the digital computers and the computational aspects. There's many advantages to that, and I think that that will become obvious as we go further down this pathway. So, any questions about that?
No.
Okay. Well, let's see. Now, the next is discuss the state of the structural modeling web application. So, had adventures in web application development. It's been interesting over the last few years. I've taken the algorithms and done a number of things with them. And I think the best way to think about this is the strict ordering and the general ordering web interfaces that we've been working with this last year. They are on the asymmetric side. They're working with asymmetric type of relations. And in the general ordering, when you have things that are equal, which includes symmetry, we collapse those into a class and just order the classes. So really, in that case, we are still just working with asymmetric ordering. Prior to doing this, focusing on the asymmetric logic piece, I did a number of programs in Python to deal with with the symmetric systems and the clustering and finding value in clusters. And both of these, both the asymmetric piece and the symmetric piece, are important in structural modeling, of course, but also the part where we take a combined structure that is it's a combined asymmetric and symmetric components, and we separate those. And those are the techniques that were outlined in the binary mathematics component. It was published by Warfield, I think, in '73. So we're focused right now on this web application software, just on the asymmetric component. And I'm using JavaScript to do this because it's not as computationally demanding as the evolutionary algorithms or the agent-based systems that we use in the symmetric piece. And in the symmetric search cluster pieces, I used Python. And the vision actually for this software is to move it through the process of the JavaScript development, kind of to get the interfaces correct, and then integrate a Python computing engine and the JavaScript display, and then have all three of these basic functional areas be able to be addressed, which is one, either the asymmetric piece, or two, the symmetric piece, which is clustering and working with clusters, or three, the separation of a combined system into either hierarchical asymmetric system structures or symmetric types of network structures, and deal with them effectively. So that's kind of the long-term goal, and it'll be interesting to see how it works. So let me go ahead here and share this other piece of software. See, here we are, come on. Here we are, share this. Present to everyone. All right. And as usual, this software really is not quite complete, but it has a lot of features. So essentially, what we have is we have the general structural ordering, so it will handle both the strict ordering and the general ordering where we're ordering equivalence classes. Like the other web app, you just enter the size of the matrix that you're working with. And once you do that, then it brings up the matrix itself and the initial matrix display. And then you start asking questions and gathering empirical data. And then you enter that empirical data into the system, and the system itself will keep track of this. So let's say, for example, we have, over here, column 5 is north of column row 7. Okay. Enter the data. So this basically says that city 5 is north of city 7. Okay. City 7 is not north of city 5. Okay. Then we'll go city 7 is north of city 3. Enter that data. You can read it here, city 7, north of city 3. But the green is in the upper triangular. And what this particular process does is we want all of the greens in the lower triangular. When we get done, the structure of this, once the cities are ordered, should either be all green and blue in the bottom and all red or yellow in the top. So we need to swap these entries, which we do here. So we swap those entries, swap the row and column, and now we have another green, as you can see here, another green in the top. So we actually swap that one out. And the swapping process that we're doing by hand now will probably be automated in the final process, so that it will keep track and write a log of everything it does, but it will basically be automated. Service 5 and 7. So we say, okay, are the entries equal? And we'll enter this data. Well, we won't really enter it because, why? It's already there. 5 and 7, we just want to swap it. So we swap those entries. So now we can see that we have all the green in the bottom and all the red in the top. And then we want to see if we can infer any information from that. So we go in infer information, and yes, we have a blue 1 here. Actually 5. Hello?
Joe, could you remind me what the color coding means?
Sure. So the red color coding means we know a red with a 0 is we know that this is false. And a yellow with a 0 means unknown. We really don't have any empirical information at all. The green with a 1 means by empirical information, by data we've gathered, we know this is true. And then the blue with a 1 means using logical inference or logical processes based on the empirical data that we've collected, we know that this is true. So the blue 1, we didn't ask that question. We were able to determine that using logic. The green ones, we got those true answers by actually expending resources and getting information. And of course, the goal of this whole subject matter is to minimize the cost of getting the data that's necessary to complete the order. So it's really a cost minimization engineering approach that we're doing here. Does that make sense?
Yep.
Okay. So now we've been working with a matrix that's the same size, and we've moved these around. But now let's say we go in and we say city 2 and city 7 are at the same latitude. They're the same, okay? So we'll go, are the entries equal? We'll say yes. These entries are equal. And then we'll say that column number 2, or city number 2, right, and city number 7, right, are at the same level. That means we're going to collapse those 2 cities into the same row and make the matrix smaller. So let's do that. Okay. So this then makes the matrix smaller. And down here, this is as far as I've gotten, I should have a vector that says 2, 7. So that what we'll tell you is that city 2, which is here, and here, represents not only city 2, but it also represents city 7, which is not here anymore. And then once we've done this, we say, oh, well, let's look at this. We see that we have a green in the upper level here. So we'll say cities are at the same level. We say, no, they're not. And then city 5, right here. City 5 is north of city 2. And what we want to do is swap those, so we bring the green, swap the red and the green there. So let's do that. So now what this has done is it's actually completed. And we have all the green and blue in the bottom and all the red in the top. And this is the way that you start to structure and order this specific logical approach. So that's what is happening on the graphical front end. What I need to do, of course, is finish putting the vectors in here. And what I will point out is that the technology, the backbone technology that I'm using to write this specific code in is put together in such a way that we will be able to keep a history of all the changes in the model. And I haven't implemented that yet, but I'll implement that after this vectors go, and then we'll have a complete history so that you can be able to hit the back button on your browser and move forward and backward in your model. It also,
that's good. So that's like a log file of the interactions.
Yes, it's actually it's a database. It's the way that one of the features of the backbone structure, but it's a complete database. It'll keep track of everything that happens in every state. So every state of this model, we started out in state 1, then we went to state 2 and state 3. Then we'll just every state change, we'll cut a new model, and then we'll keep that specific state change model in a database. And then you can use the browser forward and back history to go and have that, pull that model up and have it redisplayed. And that's, of course, the key feature now is that's kind of someone here putting this in by hand, and it's not networked. And of course, those are the network things we need to put in later on. And also the types of features that Kevin had talked about earlier about having, keep track of the administrative documentation and paperwork and the stuff that people write down, their triggering issues and their ideas and their voting and all that. Those will be things that we can add on as entry, as different input screens to, again, go into the database. And then you would have, again, every state of the model would be saved, and then you can go back, work through the history, say, oh, it started here, it went here, it went here. So that's kind of that overview. Any questions on that?
No.
Okay, well, this is going to be the primary thing I'll be working on this month, and hope to get some tests. And I think one of the first tests I'd like to do is have someone else create a structured system, and then I would like to be able to, like get online or on the phone or something, and then use this particular model to see if I can order a system that I truly don't know what, it's truly unknown to me. All the tests in the past I've done, they've either randomized them, and the computer and I knew what the real system was, or I knew in my head, because, I just was making up the test to do it. So I'd like to do, like next month or before next month, a truly unknown test, because I think we're kind of there right now. And so we'll talk about that a little bit more. But Kevin, if you have time to support something like that toward the end of the month, I think it would be great. So,
okay,
we got that part going. Let's see. Let's check the agenda here. All right. The next thing up is the systematic review process. So I think where are we on that, Kevin? You want to say a few words about?
In the systematic literature review process, the first thing is to establish objectives for doing the review, and we started one step broader to establish a context for that, which was to look at the objectives for the whole project, not just the review paper. And I went back through the INCOSE presentations we made over the last couple of years and assembled all the things that had been mentioned and added a few. And I think there's a list of 25 objectives. And then Janet Singer went through those and selected four or five of them that were the narrower scope than the whole project. And I think we have to decide if that set is what the objectives of the paper are. So that's where we left off the discussion. And then probably we should circulate the list that she had come up with. I don't have it off at the moment because I don't have the computer with me.
Well, That's okay. I think that we can get that Janet's
Yeah,
list, right?
circulate that and just get an agreement on it. And then, as I recall, the next step is to decide what the criteria is for which papers are in and which ones are out. So when I was first thinking of the systematic review, I was thinking just review all the papers that have interpretive structural modeling, but most of them are not actually advancing the algorithm. Most of them are applications of an existing algorithm.
Right.
So we needed a more specific criteria rule in an objective way which papers are in and which ones are out. And
okay. Some rule set.
yeah, we need a rule set for that provides some level of objectivity of why a paper is in the review.
Good.
I don't think there's much strictures on what those rules are. You're just supposed to state them at the outset so that it's clear that it's not just picking and choosing which ones you want. They're fulfilling the papers for review are fulfilling some criteria. And, it could be all the papers by Warfield leading up to the Societal Systems book where he refers to all of the papers.
Yeah.
Maybe something like that. But I thought that you had some broader interest in including Hitchens and Sage, and didn't quite know which way you wanted to go with that.
Well, yeah, that's really. I think that's really a good point, and I think one of the criteria we should use in making that decision is level of effort. That looking at all of Warfield's papers up to the Societal Systems book publication, that's a fairly extensive body in itself. Then another paper with another objective would be to say, okay, given these fundamental characteristics of structure modeling and ISM that were laid out by Warfield in this publication, let's say Societal Systems, if we want to use, have to pick a criteria, then what is the same or what's different between what Hitchens did, what's the same, what's different between what Stewart did, what's the same and what's different between what Sage did. And so I think, and then what's the same and difference between what the folks in India are doing, the top folks. Those four.
The folks where? What was the last one you said?
Oh, the people in India.
Oh.
They
most of the papers that come out of there, they don't look like they actually use the inferencing to reduce the cost of filling in the matrix. They're just using a version. They call it ISM, but I think they're just using the tiering of equations aspect, not the.
Right.
They're just fine. They're using the matrix to find the levels, but I don't think they actually save anything due to inferencing, as far as I can tell. I'm not really sure.
Yeah, I don't think they do either, but that's kind of those four things. That's kind of a paper, right? And then there's like another one we could do is saying, and as you mentioned, techniques of ISM that were based on ISM that really don't use inference, right? That do not use inference for the effective optimization. And so I think the House of Quality is one of those, where if you look at the uniform planning approach, it had inference all the way through it. House of Quality lost that. The structure of the ISM approach had the inference piece. Now there's a couple of ways that the ISM is being done that loses that inference piece.
Yeah, like like all analytic hierarchy process papers are similar. They set up. They don't use anything to establish the structure.
Exactly. And it's all, so there's a whole wide range of topics there that we could address, but I think we need to pick something that's fairly well contained, familiar to most folks, or the people that know structural modeling and ISM, and just kind of get a first one done, the first small thing, if you know what I mean. So I think that I think the next steps on the systematic review is we need to get Janet's list out.
We need to what?
That list of 4 things, the criteria that Janet Singer.
It might be that the systematic review is a little too ambitious for what we need to do for an initial paper.
Okay. Well, then
it's just kind of an ideal, but the systematic review and usual intent is to be comprehensive, and we might just try to follow the outline as much as possible of doing it, but maybe not try to claim it as a systematic review initially. Maybe at some later time we might attempt a review of all the literature.
Okay.
Maybe we proceed in a little different route. Because as I started to go through it, I realized that as you said, what is the level of effort required, and if we have a narrower scope, maybe instead of trying to do all the literature on, at least all the papers that are changing the algorithm.
Right.
Right. If we did, even all the papers that are changing the algorithm is a lot of stuff, because Warfield himself may have been changing the algorithm as they went. Certainly, the different versions of software they implemented changed the algorithm, and there's a lot of versions out there.
Yes, there are.
Already by the 80s, there was like 20 different sites doing their own algorithms.
Yep.
So it might be maybe we back away from the comprehensive intent of the systematic review and just try to follow kind of the set of criteria, doing as much as possible as a means of disciplining the paper as much as possible, because I don't have anything better than that as far as how to guide us doing a paper. But not try to hope for the level of comprehensiveness. Instead, have maybe, as you talk through it, maybe we have a narrative that evolves through half a dozen papers, and it's maybe the families of ISM that have emerged over the years, starting with Warfield and Sage and Stewart and Hitchens, and whatever other versions came out. When there was a flexible ISM, a fuzzy ISM.
Yeah, that just came out of Japan.
Yeah, some things that came out of Japan, but I suspect that the whole the things, a lot of the changes in the algorithm were never published. People just changed the software without submitting it to review. Then they often would publish the applications without the algorithm.
Exactly.
And not even the log file. Most people that published applications did not have a log file, so you couldn't track the relationship of input and output. You just they would present the final, they present the final matrix as the paper.
Yes.
and you have no idea what it means. They're mainly, there was a bias towards presenting this the basic idea that, look, this matrix has a digraph representation. And that was kind of the subtext of presentations in papers. It wasn't, look, this was the information that we put in, and this is what was inferred. That was, hardly anyone has published anything like that. I mean, that's one of the most basic things this algorithm does, is save you time through inference, and as far as I recall, almost no one has done a good job of documenting the relationship of input to inference.
Yes.
Output.
Yes. So that's.
Do you think so, Joe? Can you recall? I don't think Warfield even did a good job of that.
Well, I agree with you completely on the idea of the inference piece. And when I went back through Warfield's work, was first writing the software, and I ran into these issues that I'll be talking about at the open source conference. I simply, during a workshop with Warfield, I asked him, I said, well, do you have any matrices bigger than 36 by 36 because for me to test my software on? He had some small ones, 6 by 6 and 8 by 8 and 12 by 12. And he says, no, he said, 36 by 36 is the biggest I could do in my head. And so,
yeah.
I mean, these guys were doing this by hand, a lot of it. And then I asked him about the Canadian folks. I asked him about Hitchens. I asked him about Sage. And by way of detailing the conflicts between the processes, right?
Yeah.
And I wanted to talk with him about specifically the questions that you asked, which was, what's the difference in the algorithm, right? I never got to a discussion of the differences in the algorithm. I couldn't get past the political fight that, over the years that these folks were a barrier that they were never able to get past. And so...
Yeah, I mean, beyond the difference between the people within one group, like Christakis' implementations,
right?
They had a program. I know in one version of their Cognosystem software, they were changing the algorithm without reference back to the original math.
Yeah.
They just went and saw, there's a way to improve it by the programming. They just saw a shortcut, and it made the code a little shorter, but the inference a little weaker. Yeah, it's never documented.
Yeah.
So I think that's one of the another aspect that makes it difficult to do a true systematic review is that we can't review what's in all these people's algorithms.
Yes.
I mean, that's real. If you wanted to do a systematic review, you need to review all the algorithms.
Well,
and I mean, short of doing that, that's where we had the idea of the test bed. That at least you could subject the other algorithms to the test bed.
Yeah, I think that one of the things about publication, scientific publication, is that you should present your results so that other researchers can duplicate your results. And you can't duplicate your results unless you publish your algorithm. So it simply doesn't support the scientific process. It's simply people politically group together and say, this is how this works and this is what this means. You really can't test it. So open source is that.
I get you with the point of the open source. But as I'm thinking through this, I think the paper might be more of a call for greater systematicity in this whole enterprise, especially in how things are published, and replicability standards.
Yeah, so that's one of the reasons that the ART, the abstract relation type, and the AMEI were invented. So we'd have some kind of standard to talk about, so that, oh, this is the way you present your data in this format. This is kind of a set of categories by which we can talk about the logical pieces. One paper that we're going to, that Marion Thomas and I are going to do, either for NCOSE or for CSER, I'm not quite sure how the CSER thing is going to work out, is we're going to expand the AMEI to the next logical step. And so we define a system as a relationship mapped over a set of objects. And in the AMEI, we just focus on the logical properties of the structuring relationship. And so now we're going to take that and we're going to map objects. So what is the minimum, start out with what is the minimum number of objects that are required to create a system using this, a structuring relationship that has these types of logical properties. What are the minimum number of objects? And so that ties right back into the neurology, I believe, that you talked about last month. Ties into many other areas where I've seen what I believe are just logical fallacies and logical questions, or very questionable logic in the literature. So that's going to be something that we're going to do. And there are, I think, a number of other joint paper projects that we could do. Like Janet brought up the idea of the binary matrix. Well, how do you actually separate, a combined system into a hierarchical system, asymmetric, or network system, which is symmetrical? And what are the implications of using reflexive or irreflexive? And what are the advantages? Again, these folks were doing a lot of this by hand and graphing it out, and so they didn't really have the constraints with the computing algorithms, the compilers, and the mathematics that we have when we're using computers. So there's a whole series of papers there that we could do, and I think that we just need to decide if we want to have a collaborative effort for something for NCOSE IW and something for CSER. So, and I think that
For what?
For the what? The Conference on Systems Engineering Research, CSER.
What is it again?
So there's two conferences. Well, there's the NCOSE International Workshop, which happens in the January, February timeframe. And then there's the Conference on Systems Engineering Research. That usually happens in the spring, March, April, something like that. And I believe Janet is chairing a session on system science in that particular conference. And so I asked if you could present remotely, and they said, well, you have to have one of the authors has to be registered. So if Janet's going to be there anyway, right? And if she's interested in working with us on any one of these numerous topics we talked about, we may have the opportunity there to simply help be co-authors on the paper, and then she would have an opportunity to present it if she wanted to. So that's kind of a whole bunch of ifs, but those are my main view of that right now. So Well, that's good. So we've gone through here. We got 10 minutes left to wrap up. And we've talked about a whole number of things. But I think what I hear you saying, Kevin, about the systematic review is actually a step, kind of look at the approach, but don't apply that type of rigor to our activity.
Yeah. I mean, I've kind of evolved my thinking on it a bit to kind of writing about the dilemma of wanting to do a systematic review, and that kind of the quest for more of a scientific community approach to this important work. You know, the fact that algorithms are not documented in hardly any papers. There's no log files to show the relationship of input to output. People don't even necessarily refer to the version of ISM that they're using, because you'll see a lot of papers refer both to Stewart and Warfield, and which one are they using, you know?
Exactly.
And then what call ISM is not the same for everyone, because like a lot of the papers in India just looks like they fill in the matrix by hand.
Yes, it's the term has become overloaded and very polluted. It's not very specific anymore. So
the nice thing about the term is it hasn't been co-opted. You know, interpretive structural modeling, it gets you into the family. No one else is using the term interpretive structural modeling versus interactive management, for example. There's like a phone company called Interactive Management. Called Interactive Management. There's financial managers that are called interactive management. That interactive management is totally co-opted.
Yeah.
But interpretive structural modeling still means something in the family of algorithms. And so that stood the test of time. So that's one good aspect. Structural modeling by itself, of course, you get cross hits with people doing finite element analysis and architectural stuff.
And of course, statistical structures and things. But myself, I think that all those are the structural modeling approach. It's general enough to apply to all those, but they do have specific areas of expertise. So I think that what we need to do now actually is I'm going to write up, I'm going to do, like, in the next couple of days, I'm going to propose 3 areas for joint papers and just circulate it. And
3 areas for papers?
Yeah, from my mind. And I'd like, would you mind doing the same, like within the next week, just so we can kind of start circulating this and decide what we're going to target and what we'd like to do?
Yeah, it's going to have to, I'll be on the road all this coming week, so it'll be the following week.
Following week, okay, so that would be the week of, let's see, 12th.
12th.
Yeah. Okay, the 12th. Okay, I'll get mine out the week of the 5th, and then sometime, and you'll get yours out the week of the 12th. Okay, and then we can decide what we're going to do, if anything. So it's actually going along fairly well. I'm encouraged by the process and with the software, and we'll see what kind of response we get from the software community. But I do think we should actually formalize, 2 or more papers for these upcoming events and start getting this information out there in a little more formal form. Is there any other questions, comments?
No.
Okay, well, I'm just going to summarize this a little bit. I think that where we are right now is one, is there's the effort to add the objects and the object information to the MEI approach so that we now will be addressing valid structures, valid concepts for systems that have valid logic and a valid number of objects, and the reasoning for that. Map that over the MEI buckets so that we can start to identify language types and representations of valid logical systems, which again ties, I think, strongly back into the information that Kevin presented last month on neurology. And then we're going to work the, so I'm going to work the software, and I'm going to work on having hopefully an independent test here, a small one before next October, and also have before the next meeting in October better demonstration of the capability of the software. And of course, this is the last month that we'll be doing Google Hangouts. We're going to be changing over to, I guess it's YouTube Live.
What is that? They're phasing out Google Hangouts?
Well, Google Hangouts is connected directly to YouTube, and it's owned by the same company.
Yeah.
So what's happening now is Google Plus, which supported Google Hangouts, right, is changed its interface, and as part of that, they're moving this Hangout function is going to be moved over to YouTube. It's going to be YouTube Live.
Oh.
And so I need to schedule the events in the YouTube Live system, and I need to learn that, whatever that is. And so, as I said, about the middle of September, I'll be doing some tests to make sure that I understand how it works, and I'll be sending out new information on that.
All right.
So, okay, so I think we're pretty much set up to go for the next month and get some things outlined. Any final comments?
No.
Okay, well, thanks for making the effort to join today, Kevin. I know it's tough doing it on the road. Trying to get out there and...
Yeah, it was a little tricky today. I had more than one problem than being on the road.
Yeah, you know.
My phone somehow got out of sync with my email account, and I couldn't even send you email from the phone.
It happens. It happens. I've had my systems fail at the most inopportune time. But this has worked out well. I'm encouraged by this, and we'll just keep going forward. So,
okay.
Mary, you have any final comments?
Nope, just stay safe out there.
Okay. Take care. Have fun. Hey, Alexander, you ready to go?
I'll discuss it later.
Okay. Sounds good. Take care. Well, this will now be signing off.